Hi everyone, and welcome to Metaphysical Mining. My name is Michelle DeVries. This is part 2 in the 3-part series of an introduction to metaphysics. In part 1, we determined that metaphysics is a branch of philosophy that studies the ultimate existence of reality and experience without being bound to any one theological doctrine or dogma. I used the umbrella analogy from my marketing background to more easily organize the disciplines that are concerned with the fundamental nature of reality and being, which includes cosmology, ontology, and epistemology. For each category, I briefly covered the definition and gave examples of questions that best represented the goal of each discipline. For example, a cosmological question would be, how did the universe begin? An ontological question would be, is there a God? And an epistemological question would be, what is knowledge? In part 1, I also showed what the metaphysical umbrella looks like in regards to the disciplines of cosmology, ontology, and epistemology. The bullet points below each section are broad examples of topics that could fall under these disciplines. Of course, this is not a comprehensive list, but a good conversation starter. Now, the next step in understanding metaphysics is how to move beyond the academic conversation and discuss the topic out in the real world, which is what this video will cover. I have 2 go-to examples for when I'm speaking with someone who wants to quickly wrap their head around the topic of metaphysics or someone who has a short attention span. And that first go-to answer is the placebo effect. I use the placebo effect because it's the most relatable and universal phenomenon that the majority of the population either has experienced or will experience in their lifetime. According to WebMD, a placebo is anything that seems to be a real medical treatment but is not. It could be a pill, a shot, or some other type of fake treatment. What all placebos have in common is that they do not contain an active substance meant to affect health. Researchers use placebos during studies to help them understand what effect a new drug or some other treatment might have on a particular condition. For instance, some people in a study might be given a new drug to lower cholesterol. Others would get a placebo. None of the people in the study will know if they got the real treatment or the placebo. Researchers then compare the effects of the drug and the placebo on the people in the study. That way, they can determine the effectiveness of the new drug and check for side effects. Sometimes a person can have a response to a placebo. The response can be positive or negative. For instance, the person's symptoms may improve, or the person may have what appears to be side effects from the treatment. These responses are known as the placebo effect. Research on the placebo effect has focused on the relationship of mind and body. One of the most common theories is that the placebo effect is due to a person's expectations. If a person expects a pill to do something, then it's possible that the body's own chemistry can cause effects similar to what a medication might have caused. For instance, in one study, people were given a placebo and told it was a stimulant. After taking the pill, their pulse rate sped up, their blood pressure increased, and their reaction speeds improved. When people were given the same pill and told it was to help them get to sleep, they experienced the opposite effects. Experts also say that there is a relationship between how strongly a person expects to have results and whether or not results occur. The stronger the feeling, the more likely it is that a person will experience positive effects. There may be a profound effect due to the interaction between a patient and healthcare provider. The same appears to be true for negative effects. If people expect to have side effects such as headaches, nausea, or drowsiness, there is a greater chance of those reactions happening. The fact that the placebo effect is tied to expectations doesn't make it imaginary or fake. Some studies show that there are actual physical changes that occur with the placebo effect. For instance, some studies have documented an increase in the body's production of endorphins, one of the body's natural pain relievers. MichiganMedical.org states that today scientists define the so-called placebo effects as the positive outcomes that cannot be scientifically explained by the physical effects of the treatment. Research suggests that the placebo effect is caused by positive expectations, the provider-patient relationship, and the rituals around receiving medical care. Few of the conditions that respond positively to placebos are depression, pain, fatigue, allergies, irritable bowel syndrome, Parkinson's disease, and even osteoarthritis of the knee. The power of the placebo comes down to the power of the mind and a person's skill at harnessing it. Elements of the body once thought to be outside of an individual's control are now known to be modifiable. A legendary example of this is Tibetan monks who meditate to generate enough body heat to dry wet sheets in 40-degree Fahrenheit temperatures. Furthermore, multiple brain imaging studies demonstrate changes in the brain in response to successful placebo treatments for pain. There is even evidence that individuals who respond positively to placebos show increased activity in areas of the brain that release naturally occurring opioids. Emerging research suggests that even when people know they are receiving a placebo, the inactive treatment still has effects on the brain and reported levels of improvement. The placebo effect is recognized as being powerful enough that the American Medical Association considers it ethical to use placebos to enhance healing on their own or with standard medical treatments if the patient agrees to it. Clinically, doctors use the principles of placebo in a more subtle way than it is used in research studies. A 2013 study from the UK found that 97% of physicians acknowledged in a survey having used some form of placebo during their career. This might be as simple as expressing a strong belief in the likelihood that a patient will feel better from whatever treatment the doctor prescribes, even if the treatment itself is not chemically powerful. There is now even an international society for interdisciplinary placebo studies. They have written a consensus statement about the use of placebos in medicine and recommendations for how to talk with patients about it. In the past, patients who improved from a placebo effect might have felt embarrassed as if their ailments were not real. In 2002, a study supported by a grant from the Department of Veterans Affairs was conducted to test the efficacy of lavage and debridement in patients with osteoarthritis of the knee. In the discussion section of the study write-up, we have the following. This study provides strong evidence that arthroscopic lavage with or without debridement is not better than and appears to be equivalent to a placebo procedure in improving knee pain and self-reported function. Indeed, at some points during follow-up, objective function was significantly worse in the debridement group than in the placebo group. The study reported that if the efficacy of arthroscopic lavage or debridement in patients with osteoarthritis of the knee is no greater than that of placebo surgery, the billions of dollars spent on such procedures annually might be put to better use. This study has also shown the great potential for a placebo effect with surgery, although it is unclear whether the effect is due solely to the natural history of the condition or whether there is some independent effect. The study suggested that healthcare researchers should not underestimate the placebo effect regardless of its mechanism. According to a Harvard article, the power of suggestion is a double-edged sword. If you expect a treatment to help you, it may be more likely to do so. And if you expect the treatment will be harmful, you are more likely to experience negative effects. That phenomenon is called the nocebo effect, from the Latin I shall harm. For example, if you tell a person that a headache is a common side effect of a particular medication, that person is more likely to report headaches even if they are actually taking a placebo. The power of expectation is formidable and probably plays a significant role in the benefits and the side effects of commonly prescribed medicines. Imagine the harm that a physician can do if an individual has an intense trust in what they say. Why do doctors just blindly repeat things like at age 40, you will need reading glasses? I have personally set out to disprove my eye doctor for saying such a thing. And so far, at almost 48 years old, I can read just fine without readers. So if an eye doctor really had their patient's best interest in mind, they would say something like, most of my patients don't ever require reading glasses. I don't understand, but for some reason, I seem to attract patients that just don't need readers. But instead, we have the opposite. And I honestly wouldn't be surprised if doctors started lowering the age requirement for readers just so that they could sell more product, which is what occurred with the cholesterol levels since the 1970s. And I got that bit of information straight from a cardiologist who was angry that my primary care physician referred me to a cardiologist just because my cholesterol was quote unquote high, even when my ratios were perfectly healthy. This cardiologist educated me back in the early 2000s on the truth about cholesterol numbers and how he had noticed the recommended cholesterol level was slowly dropping over the years, and in his opinion, it was only to sell more drugs. Needless to say, I left his office without medicine. Please take all of this into consideration, both the placebo and nocebo effects, the next time you get some advice or suggestions from any type of physician, because your beliefs do have a huge effect on your health, which is a perfect lead into my second go-to answer to anyone that's having trouble wrapping their head around the concept of metaphysics, or for anyone who has a short attention span, and that topic is epigenetics. Now, according to Harvard, epigenetics is an emerging area of scientific research that shows how environmental influences, also known as our experiences, actually affect the expression of our genes. This means the old idea that genes are set in stone has been disproven. Nature versus nurture is no longer a debate, it's nearly always both. During development, the DNA that makes up our genes accumulates chemical marks that determine how much or little of the gene is expressed. This collection of chemical marks is known as the epigenome. The different experiences we have rearrange those chemical marks. This explains why genetically identical twins can exhibit different behaviors, skills, health, and achievement. Epigenetics explains how early experiences can have lifelong impacts. The genes children inherit from their biological parents provide information that guides their development. For example, how tall they could eventually become, or the kind of temperament they could have. When experiences during development rearrange the epigenetic marks that govern gene expression, they can change whether and how genes release the information they carry. Thus, the epigenome can be affected by positive experiences such as supportive relationships and opportunities for learning, or negative influences such as environmental toxins or stressful life circumstances, which leave a unique epigenetic signature on the genes. These signatures can be temporary or permanent, and both types affect how easily the genes are switched on or off. Recent research demonstrates that there may be ways to reverse certain negative changes and restore healthy functions. Young brains are particularly sensitive to epigenetic changes. Experiences very early in life, when the brain is developing most rapidly, cause epigenetic adaptations that influence whether, when, and how genes release their instructions for building future capacity for health, skills, and resilience. Supportive relationships and rich learning environments generate positive epigenetic signatures that activate genetic potential. I was first introduced to epigenetics through Dr. Bruce Lipton. In fact, the first metaphysical type book I ever read was the book pictured here, titled Spontaneous Evolution, Our Positive Future and the Way to Get There from Here. Dr. Lipton is one of the leaders in epigenetics. In fact, he was talking about epigenetics way before anybody else, and was even ridiculed and ignored by his scientific peers years ago when he was a researcher at Stanford University School of Medicine between 1987 and 1992. At that time, he revealed that the environment, which operated via the cell membrane, controlled the behavior and physiology of the cell, turning genes on and off. To give you a reference point, the Human Genome Project didn't start until October of 1990, 3 years after Dr. Lipton's work. We've come a long way since those days, and I've included a link to the interviews with Dr. Bruce Lipton on the London Real YouTube channel. I highly recommend them, as well as the many other interviews and lectures by Dr. Lipton available on YouTube. His books pictured here are available anywhere books are sold. According to the CDC, not all epigenetic changes are permanent. Some epigenetic changes can be added or removed in response to changes in behavior or environment. The example that they gave was smokers versus non-smokers versus former smokers. And they report that smoking can result in epigenetic changes. For example, at certain parts of the AHRR gene, smokers tend to have less DNA methylation than non-smokers. The difference is greater for heavy smokers and long-term smokers. After quitting smoking, former smokers can begin to have increased DNA methylation at this gene. Eventually, they can reach levels similar to those of non-smokers. In some cases, this can happen in under a year, but the length of time depends on how long and how much somebody smoked before quitting. Now, according to a Harvard Medical School article published in January of 2023, an international study demonstrates for the first time that degradation in the way DNA is organized and regulated, known as epigenetics, can drive aging in an organism independently of the changes to the genetic code itself. The work shows that a breakdown in epigenetic information causes mice to age, and that restoring the integrity of the epigenome reverses those signs of aging. The paper's senior author, David Sinclair, believes the study is the first to show epigenetic changes as a primary driver of aging in mammals. The team's extensive series of experiments provide long-awaited confirmation that DNA changes are not the only or even the main cause of aging. Rather, the findings show chemical and structural changes to chromatin, the complex of DNA and proteins that forms chromosomes, fuel aging without altering the genetic code itself. Remember that this is just a brief introduction to the placebo effect and the topic of epigenetics. There are numerous scientific studies published online and many YouTube videos dedicated to both topics. The intent of this video was just to get you started down these paths if you are interested, as well as getting you to shift your perception on how you can use the power of your mind to both shape your reality and heal your body. It's no longer a woohoo topic. It's actually mainstream science. Thanks for listening, and remember to subscribe to receive notice of new content. Part 3 will be available soon. I'll see you then. Thanks.